Hello and welcome. This video is a step-by-step instructional guide to the first exercise in RTsim.Career called Buffer Tank. Let's get started. Let's click on the training button and choose normal startup of the buffer tank. To begin with, I want to remind you a little piece of theory. The buffer tank is a sealed vessel. It is used to stabilize flow rate and product quality by temporarily storing the process fluid and smoothing pressure and flow fluctuations between different sections of the process chain. In everyday life, it is used as a toilet flush tank, garden water storage barrel, and water tower. In industry, buffer tank used on any unit where a liquid product is present. This model includes three lines: a feed line, it's here, an outlet line to the unit boundary, and a drain line for removing liquid from the tank. The feed enters from the left and exits on the right. Shutoff and control equipment are installed along the pipelines. The buffer tank is equipped with a peer number 3 pressure transmitter. To see it, click on the Technological Flowsheet button and you can see it. Also, there is a Lirka number 4 level controller. It is here. Pressure transmitters peer number 1 and peer number 6 and flow controllers FIRC number 2 and FIRC number 5 are installed on the inlet and outlet lines respectively. Before startup, the tank is filled with an inert gas, in this case nitrogen, which does not mix with the incoming liquid. Dear friends, let's conduct the normal startup of this unit. I hope you remember that before starting up any exercise, you need to click at Start and Technological Flowsheet buttons. Alright, let's conduct first two steps. Open the manual valves Z number 1 and Z number 2. Our next step is opening the shutoff valve U number 3. To do it, let's go to the distributed control system. Let's click on U number 3 and open. Our next step is opening the regulating valve FIRC number 2. It's here, and we need to do it smoothly, between 5 and 15%. To open it, click here. Let's choose, for example, 15%. And then you need to enable automatic mode to it. Click here on the menu and choose automatic. Our next step is setting the set point to this device between 25 thousandths and 35 thousandths kilogram per hour. Let's make it 35 thousandths kilograms per hour. Alright, we return to our workstation field. And now we need to wait for the Lirka number 4 metric, it's here, to exceed the alarm thresholds. The alarm thresholds for this device are from 35 to 70%. You can see it here under the Lirka device. While we are waiting, I have a question for you, dear friends. Why do we crack open the control valve FIRC number 2 to just 5 to 15% instead of throwing it open to 100% right away? What do you think? Why we can't can't open it to, for example, 50%. Pause the video and make your own hypothesis, and then play the video again, and you will hear the correct answer. Alright, dear friends, the correct answer to this question is that we do it to prevent hydraulic shock. A sudden rush of liquid can rupture pipe connections, blow out gaskets, or destroy internal valve mechanisms. That's why we need to open Firka number 2 smoothly. And this rule is also applying to other regulating valves. So you can see that our level is rising. You can open the trend and you can see that it goes higher. And we need to wait just a few seconds and then we can proceed. Let's go to the distributed control system. So our Lirka number 4 exited the alarm thresholds. Our next step is open the regulating valve FIRC number 5. And okay, as always, we do it smoothly from 5 to 15%. Let's do it 5. Our next step is enable automatic mode to Lirka number 4 and set the set point between 40 and 60%. Let's make it 50. And our last step is enable cascading mode to the FIRC number 5. Click on Man and choose Cascade mode. Now let's go to the workstation field. We enabled cascading mode to the FIRC number 5, but what is it? What is the cascading mode? Cascading mode refers to a control strategy where the output of one controller serves as the set point for another controller. So that means Lirka number 4 serves as the output controller for FIRC number 5. And you can see that this regulating valve constantly opened. You can see the trend of the Lirka. It is rising, but our task is 50. So for finish this exercise, you need to wait when your Lirka number 4 is falling to the task parameters. And now you can see that it starts falling. We need just to wait a few seconds to finish this exercise. We have completed all the steps for the normal startup of the buffer tank. Dear friends, now we just need to wait some seconds and we can finish the exercise. Our task for the Lirka number 4, our set point, was 50%. And when the trend is falling to this 50%, we can finish the exercise. So it's close. To finish the exercise, you can You need to click yes without saving because we have complete all the steps. If you don't want to stop the exercise, click at the no. So we see that it's almost 50%. Yeah, and now we can finish the exercise. Click on yes without saving. Alright, dear friends, I hope this session for you was very useful and rewarding, and now you can conduct the normal startup of the buffer tank. I'll see you at the next session. Goodbye.